In this video, we're going to talk about linear combination. Linear combinations means there are a couple of vectors, v1, v2 to vn, and they are all in Rn. Rn is the dimension in real space. Linear combination is just adding them up all together. v1 plus vn plus v3 to vn. And of course, we will scale them with different constants c1, c2, cn. C is any constant, any real number. Let's use an example to figure this out. Let's say factor A is equal to 2, 3, and factor B is equal to 0, 1. The linear combination will be factor A plus factor B, which means the x is 2 plus 0, and the y is 3 plus 1, which is equal to 2, 4. Let me draw it in the graph. Factor A is 2, 3, and factor B is 0, 1. Adding them up would be 2, 4. Use the orange one. And actually, there are constants before 2 factor. There are 1a plus 1b. So let us do another example. The constants are 2 and 3. 2a plus 3b. We can copy some things first. Still, 2 plus 0 and 3 plus 1. However, this time we have to multiply the constant to the factor first. So it would be 2 times 2 plus 3 times 0 and 2 times 3 plus 3 plus 1. And it is equal to 4, 9. And let us draw it in the graph. 4, 9 here. And it is new combination. And what does span mean? A spanning set, factor A and factor B, conclude all values in R2, which means their combinations help you to go wherever you want in that space. Look at the graph. You can go to this point, or that point. Let me draw the original factor. Then by scaling them, you can go to different points. See, in R2, you can go to whatever you want. But always remember that factor 0 is always equal to 0, no matter what constant is multiplied to it. Let's talk about set that does not span. Still, we are adding different factors together and scaling them with different constants. However, no matter how you combine them, you can just move on the same line if the set does not span. Let's give an example. If factor A is equal to 2, 2, and factor B is equal to -2 and -2, they does not span, because no matter how you scale them and adding them up together, you are still moving on the same line. Maybe it is equal to negative 1b factor b, negative 2 factor b, or it is equal to negative 1 factor a, or negative 2 factor a, even negative 3 factor a. Still moving on the same line. I got a tips for you. The angle between them is always and always equal to 180 degrees. Just like the angle between west and east. West is 270 degrees and east is 90 degrees. So the angle between them is always equal to 180 degrees. Or let's see it in a compass. If it is north 45 degree east, then the set that does not span the vector. Another factor would be the direction would be south 45 degree west. The angle between them is always equal to 180 degrees. The set does not span, which means you can't go wherever you want. You can just move on the same line. Let's talk about spanning set in R3. In R3, there would be one more axis, so one more component. Factor A would be equal to x1, y1, and z1. Factor B would be equal to x2, y2, and z2. And scaling them by different constant, c1 and c2. There are two requirements or two conditions that the set spans. First, they should be non-zero. Second, they should be non-collinear, which means they are not parallel nor scalar multiple of each other. The yellow plane is the combination of factor A and factor B, a plane. Let's move it into the graph. And we can see that if it spans, we can turn it like this and that, or make it bigger or smaller. And it spans. It means it spans. A spanning set in R3 is still the same as in R2. You can go wherever you want.